content falls within the guidelines. I can't stress that enough, because if your recipe happens to be chosen to be one of the top 10 from the preliminary reviews, if the recipe that you have coming to the final is not meeting those nutritional guidelines, then your recipe will be omitted as being a contender for the final. So make sure that you have that. And if you have any questions, because I know some of the recipes I've had to send back to some of the schools and say, your nutritional breakdown doesn't make any sense based on what you had submitted. So if there are questions that you have over that, feel free to email me, and I will get in touch with the food lab, and they can help make sure that you have the right that you're actually reporting the right, saturated fat or fat content, things like that. So we're here to help you. And so if you're struggling with that, we want to make sure that you guys get the help you need on that. So, once we get all of these recipes back to you guys, then y'all can work on them. On February 3rd, you'll be doing your preliminary. I believe my last preliminary is going to be early March. Okay, and so I'm going to try to be very quick about making all those calculations from after that, and then I will get back with you guys very quickly at that point to let everyone know who the top 10 are and who will be invited to come to Johnson Space Center. The Space Center Houston is where we're going to have the final again this year, and I'm still working with them. It should be toward the end of April or the beginning of May that we're looking at for having the final culinary challenge. I'm sorry that we don't have a date for that set yet, but we're working on that right now, trying to get that finalized with them. They're trying to figure out where they're going to put us, if they're going to put us in the same location we were in last time, or if we're going to be in a completely new building that they're actually building currently that has some more kitchen space. So the contenders, the final 10, those people are going to be responsible for making sure to have a final paper and having a video, a 2-minute video. And all of my requirements for that are on the website. So you can go in there and feel free at any time to ask me any questions in regard to that. The other thing is, just so you're aware, the evaluations that are done for you during your preliminary reviews, the sensory evaluation sheet, that is the same evaluation sheet that the Johnson Food Lab uses for any food that they're going to fly, that they have the astronauts review. So just so you're aware, everything, your sensory evaluation is the same throughout. So everybody that's doing this preliminary competition, they are all using the same form and the same format for how their foods are reviewed for the preliminary challenge. So I think that's all I have. I'm here to answer any questions that you guys might have.
All right, so Passaic or Windsor, those are our two schools that are in that culinary challenge. Do you have any questions for Ellie? Thank you, Ellie. You did a great job explaining that.
Sure.
It's Rob at Passaic. At this time, we don't,
I think you froze on me a little bit.
If I do, can I always reach out to Allie or you, Flo, with any questions?
Okay, awesome.
But at this time, no, we're pretty good with it. Thank you very much.
Okay, thank you.
Good. How about Windsor? I saw Green. Yes.
I have my team here. I'm here with Ms. Green and the 7 students, including the young lady who's doing the video, Taylor. So I have 3 teams here, and I'm going to encourage them to ask you questions.
Okay.
If they do need to make small tweaks,
Okay.
when does that have to be done by?
Oh, if they have to make small tweaks, when does that have to be done by?
Before your preliminary challenge.
Okay, and
so between probably December 14th is maybe when I'm going to be returning all those recipes out to everybody.
Okay.
Between then and February 3rd is when you're going to need to have your, kind of really have your recipe finalized at that point. So, and also, of course, like I said, not really deviating from the recipe that you submitted originally, like that, you originally get, don't give me something for peanut butter cups and then now you're going to give me strawberry pie. You know, I mean, it's got to be the same recipe, but just you can tweak it, but just make sure that the nutritional guidelines are still met.
Okay, thank you.
And are you able to come down to Passaic County Technical Institute in Wayne, New Jersey on February 3rd at around 11 a.m.?
I asked Matt Dodona, who's the new curriculum supervisor, and he's going to get back to me on that.
Okay, good. Well, Matt was a hunch teacher, so he knows all about our program.
Right.
Not the culinary part.
Well, it seems like food, all right.
Yeah. Good. All right, well, will you keep me informed on that?
I will. Well, I think the students all kind of wondered if they were on the right track on their recipes. So I'm going to hand over the floor to Katerina and Jasmine, first of all.
Good.
Graham Crafter, I was asking what they thought of
it. So we were debating on how we should make the crust for the cheesecake. We weren't sure if we should do the pecan and almonds for the crust, or if we should use graham cracker crust. Since it's going to be out of space, we're like not sure about that.
Okay, but you guys already submitted your recipes to me.
Yes.
Okay, so what was the crust that you had in your recipe?
We had the almond crust.
Okay, so at this point in time, what's going to happen is that the Johnson Food Lab is going to be reviewing your recipes, and they're going to be looking at the ones that that they feel are more processed, most likely to be processed for flight. So they're going to look at those, and they're going to return back to you guys one recipe per 3 that you submitted, right? Okay. So if the recipe that gets returned back to you happens to be that recipe, then at that point in time, I can ask that question to the Johnson Food Lab.
Okay, thank you.
Mm-hmm.
Any other questions? Okay. I don't think my crew here has any more questions. They've been working hard on it and are enthusiastic about it.
Awesome. That's great. That's great. Yeah. And they'll get some results back. And then if there's more questions after they get the results back, then I encourage them to send me those questions, and I can get in touch with the food lab and make sure that they are answering the questions that you have.
Thank you so much.
Thank you.
Thank you guys for working on that dessert. That sounds awesome. And try your best to get down there on February 3rd. But if you can't, let me know.
I will reach out to Matt tomorrow again and make sure he knows about it and see if we can go. The town really supports this program.
That's awesome. We appreciate that. And you guys were in the top 10 last year, so you're right in there. So that's great.
Thank you.
All right. So Windsor, are you going to stay on for some of the other projects, or you're not? I know you guys are working.
I have one young lady that's doing the video. Should she stay on?
No, she doesn't have to stay. And the tape dispenser that you guys are working on, they don't really have to stay today either. Everyone
here is Culinary.
Yeah, I just have my...
Okay.
Oh, Sean is here for both.
For?
The tape dispenser, and he submitted one of the desserts as well.
Okay, well, I have, he's in both classes then. That's awesome. Yes. So he could stay, definitely. And I do have the tape dispenser right at the bottom of my list because he's the only one doing it.
Oh, yeah, he has to go to work. He works at Moe's Mexican place around here.
Okay, well, tell him no worries. Thank you for coming. Thank you.
So, Flo, I'm going to stay on, but I'm going to turn off my video, and I'm going to be listening in and watching, okay?
Good. So. We can always use your help. Thank you so much.
We're going to excuse ourselves. I got a class, and Mr. Castaneda.
Yep. Thank you. Thank you, Rob.
Thank you.
Thank you,
Bye.
guys.
Bye, Allie.
Bye. Thank you.
All right, so then the next person I'm going to introduce, and some of you have already met him, is Glenn Johnson. And Glenn, you want to say a few words, and we're going to get started right away with your knee board
Okay.
project.
Okay. Can everybody hear me okay?
Yeah, we hear you.
Okay. All right. So, let's see. We've got a lot of projects. What are we looking at as our first ones here? You said the
First one is the knee board.
Okay.
So,
And that sounds great. So we've got Grafton, Swanson.
so
Okay.
we do have some schools there who are doing the knee board.
Okay. Now, it's interesting. So I started off with this project thinking that with the understanding that the crew office, the astronauts had just recently chosen a new version of the knee board to fly because they had run out of their old version. But when I started, I'd heard that everybody was satisfied with it. But after I started talking to a few, they said, no, we don't really like it. That's just the one that we all ended up getting. And so overall, I was expecting people to just come in with new ideas of things that you could add to that board. And now I'm hearing from the crew members, no, if we had something better, they might be interested. So initially, I think you should plan on saying, hey, for the knee board, can we, what can we add to it? But then if you start looking through other knee boards and realize, hey, there's something better that we could do than what we've seen, I'm okay with that. So you can expand this a little bit and it wouldn't hurt anything. Let's see. I brought along a double ball clamp so that I can show you how those work as well. And looks like you guys have a lot of stuff going on, so that's pretty exciting.
That's good. So let's ask the people who are doing the knee board, do you have any questions about that? So Glenn has just changed the paradigm a little bit, that you could actually do research online and find a better knee board than what we've been saying is the knee board that the astronauts are using. Like, they're not totally sold on that knee board. And an important concept that everyone should know is that you don't necessarily have to reinvent the wheel. If you can find something online that is better than what we have now, or could be used for something we want, you should do it. And that's an important part of the research, that you don't have to reinvent it. You can work on that without that.
That's right. And so sometimes the best engineering is not to reinvent something or come up with something completely original. Sometimes the best engineering is to be able to find something that already works and be able to just, if you have to modify it a little bit, that's much better than starting from ground zero. So, all right. If anybody has any questions, I'd be glad to answer anything about the knee boards.
So who listening is working on the knee board? Can you speak up a little bit?
We are.
Okay, that's our Virginia school.
Okay.
And did you have any questions about the knee board?
We actually have several.
Okay.
First one I would think has to be, does it have to be on the knee? Like, are we allowed to reposition this to maybe the arm?
Huh. I hadn't considered that. It's not unreasonable to suggest that they have like an arm board or something like that. So if that's something, it would probably be a much smaller board. Is that what you're thinking?
Possibly, yes.
Sure. I don't think it would be a bad idea to make a suggestion like that.
Okay.
Okay.
Do you guys have hard copies of these that we could send out to schools? Because currently we have like a 2D picture of what we're working on.
We don't have any of these knee boards to be able to hand out to people or pass around. We buy as many as what the crew needs on orbit, and then maybe we have one here on the ground to be able to, compare to what any kind of program we're working on. If you guys wanted to buy one online, I can't remember what they are. Do you remember what they were, Flo?
I actually have the link for that.
Was it like $40 or something like that?
Yeah, it's $40. It's from Lake and Air, and your mentor should be able to purchase that for you. Who's your mentor there? Who's your NASA mentor?
That would be Joseph O'Connell.
Okay, so we'll make sure that he gets that link for that knee boards, because if you don't have one of them, it's a big advantage to have one for $40. You've got a hard copy of that knee board.
Okay. And then the next question would be, how far are we allowed to modify this?
Well, so if you're trying to add something to the board, then you don't want to modify the knee board at all. If you're trying to come up with a whole different knee board, then you're having a whole different conversation. And so remember, your first thing is you're just trying to show a concept, and the more clearly you can describe that concept to somebody else, the more likely we're going to be able to go forward with your idea. Okay, so the first one that you show us, let's see, the first one that you show me is going to have may not be the correct materials, and that's okay. Just tell me what kind of materials you are planning to make it out of. All right. I've got some people that are making like some kind of a box or something like that holds more things in it, and so they're just trying to represent it as best as they can, and then they show me how it's going to attach to the knee board, and that's just fine. Whatever you think is going to make it easy for you to describe what it is how your idea is different than everybody else's. Okay.
So what I have my students doing is that I have bought them those knee boards, and then they are adding things to it. So instead of just being able to hold a pencil and a paper, it's going to be able to hold an iPad, or they might have a little sack to it to hold some other utensils, or something tethered to it. So it's modifying the one that they're using now. Is that okay, Glenn?
That's right.
Yeah. So that's a good thing. Do you have any more questions there?
I do believe we have one more.
Okay.
So last time or at least the last time I participated in Hunch, we were making a hermetically sealed camera case, and we were told not to use hinges. Does that apply here as well?
I don't see why you wouldn't be able to use hinges. Hinges would be fine. You want to make them so that you're not going to get something pinched in it or something gets caught in it. I don't see why you wouldn't be able to use a hinge. Okay. And there's lots of different types that you can look at. I've got one group that's working on. It's kind of like a cloth hinge, and that's okay. If you want to use a steel pin or something like that, we use hinges on a pretty regular basis on the station, so that's not a problem. Okay, good.
Questions? Any other question from that school?
What? Oh, we did? Okay, so you're good.
How about who else is doing knee boards?
Airport?
Fairport, let's hear from you guys. So they're in Fairport, New York.
Yeah.
I guess.
So we were wondering exactly what kind of tools you wanted us to include, because we had scissors, flash drive, pencil, iPad, and that was about it. And we were also thinking about including things from the pin kit, like the wires.
Oh, I hadn't thought of that. That's actually pretty good.
Mm-hmm.
And so occasionally they'll take out like some small sockets. I mean, we don't use like 1-inch bolts or anything like that, so we don't have great big sockets. So they might have 2 or 3 sockets that they would be floating around to carry with them, and they might have like a driver, just like a socket wrench driver. So it might be either a socket wrench, or it might be like kind of shaped like a screwdriver handle kind of thing that would fit the sockets. The fact that you said scissors is actually a really good one. I'm glad you mentioned that. And the thumb drive is creative. I hadn't thought of that. That's a good idea too.
Mm-hmm.
So those are good.
Snap-on tools. You mentioned that in one of your emails, Glenn.
That's right. For the most part, most of the tools are just standard, off-the-shelf, snap-on tools, hand tool kind of things. And so those are probably the more common tools that they would be carrying around.
And it's a mini iPad, not the big iPad, a mini iPad.
Yeah, I think it's an iPad 2.
Yeah, it is. Flo had us use an iPad 2 for our dimension.
Okay.
Good.
Other thoughts? I see is that a mock-up of what you've got, what you're thinking about there?
Yes, those are the things that we have the ability to include on our first prototype.
Yeah, we have a couple of them. We have one that's kind of based off of like a traffic keeper type binder.
Yep, I see it. Oh, very good. I like that idea.
We literally just ordered a binder and modified it.
That's a great idea.
So,
And we have our original soft prototype, which included many zippers. That the first one included the elastic pull taut that tools could just be readily placed in here.
Yeah.
The next zip had the iPad directly in it.
Uh-huh.
And the front would eventually have clips for the the legal pad or notebook paper, and it would just go directly on the top.
That's a good start. I like that idea. Good job.
Yeah, that looks awesome.
Are those the straps that you've got on the back of it there?
The straps, yes, they are. Currently, we're using backpack clips, but we need to find a better solution for keeping it attached to it.
No, and a backpack clips are very similar to what they use now, so that's not a bad description. Okay, good thinking. Good job.
Good. Any other questions from Fairport?
What were the size of the scissors that they used on the ISS?
The size of the what?
Scissors.
Like the lengths.
Oh, the scissors. Gosh, hold on a second.
It's a smaller scissors.
They use a lot of different scissors, or there's a couple of different types of scissors. The most common ones are the ones that they use for their food.
Mm-hmm.
So I wish I had I don't have that type with me. So I just pulled out, these are regular scissors. The ones that they typically use, the blades are about that long, okay? They're similar in length. The blades are only about that long, and then it kind of extends a little bit back further. So they look a little bit like what you might see for like surgery or something like that. They're more closely, they look more like that to me than like the scissors you might have in your desk drawer.
So you might have to put the scissors on a diagonal in your case, because you don't want your case to get too long, too bulky.
That's right. Yeah. Try to keep it small as best you can, because once it starts getting too big, now it bumps into things as you're floating past everything. Okay.
So currently, the dimensions that we might be using is 18.5 centimeters by 23.5 centimeters along the side.
Okay. So that's similar dimensions that you're holding up there as to what we're talking about. Excellent. Okay. So those are similar. That's good.
Are there any materials we should refrain from using?
I wouldn't worry about it right now on your first design. First, let's take a look at everything. Represent your idea first, and then we'll start talking about materials. The kind of materials that we try to use on the station are often like Nomex, because it's a non-flammable kind of cloth. We use a lot of aluminum. We try to avoid, let's see. So like the kind of plastics that we use most often are polycarbonate and Teflon, because they have a very high temperature. They don't melt or burn very easily. Okay. But let me back up a little bit. The one that we have on orbit, the knee board that we have on orbit right now is it's just straight off the shelf. So those are not made out of Nomex and things like that. Okay. So it doesn't mean you can use anything you want. It means, plan on trying on when you're describing your idea, try to come up with materials that are low flammability kind of things. Okay.
Would you entertain the idea of using something like leather?
Yes.
Leather?
Oh yeah. Yeah. As a matter of fact, we're working on some slippers for the astronauts that use leather.
Yeah, that was fair work.
Yes, you guys were part of that. Very good. I'm. Oh, here, let me show you.
I'm like 10 feet away.
Here's the pattern that we're using, and it used some of the same kind of ideas as what you guys were working on. One of our schools mentioned how we're using how you can use the laser engraver to be able to put the astronauts' patches on the slippers as well. So we're doing some cool stuff. Thanks for you guys having good ideas. All right, keep it up. All right.
The school previously in Virginia has another question.
Yeah.
Go for it, guys.
Okay, so you guys mentioned tools being in the reports. We were thinking the same thing, but we don't know like what kind of hand tools they have available to them. So could you include those sets along with your link to the NEED site?
Yeah. So the which school am I talking to? I can't tell here.
The Virginia school.
Pocosin.
Pocosin. Oh, okay. All right. Okay. So if you go into the onto the web page, you should see one. Allie, I can't remember which the one with the toolbox. Do you remember what that one's what's that one's called? I think maybe it even says toolbox.
Tell me again. What are we looking for?
On the web page, one of the sets of pictures that I included was the pictures of all the tools in the toolbox. Is it just called ISS Toolbox, maybe?
Let me look. Okay, I'll look while you're still talking. Okay.
So if you look through that presentation, you'll see that there's quite a bit of options of what kind of things they might use. And remember, not all of them have to fit on some kind of a knee board or anything like that. So it's just something to look at and to consider. That's all. I mean, obviously, they don't want to put a great big hammer hanging off of their knee board, right?
Right. Fairport, did you have any more questions on the knee board?
No, we do
we're all
not.
set. Thank you.
Thank you.
Okay, good. How about, is Glenelg there? Is the school in Merlin still there? I know they were on earlier.
Actually, we do have a question.
Oh, there you are.
So, regards to the socket wrench drivers, we were actually wondering if you guys had to choose which ones you guys preferably use.
What size socket do you use?
All right. So they're typically using the smaller ones, and so they often use the quarter-inch driver. So that might be an easy way for you to, depending on how you attach them. You know, you might put the sockets onto kind of a socket holder that's a quarter-inch or something like that. And so I think it's like a 5/16 is a very common one. You might use a quarter-inch, and you might use something a little bit bigger than that. Okay. In general, that's pretty much the sizes that they use for sockets.
Okay. Yeah, thank you.
All right, thank you.
Sure.
Is that your only question, Glenelg?
Yes, we only
For
had.
the keyboard? Okay, how about North
Hey,
Carolina? Yeah, you found something? Ellen?
So yeah, so if they go to, can I share my screen or no?
Sure.
Yeah, sure.
What do you think?
Let me see if I can.
On the bottom, right?
Yep. Okay, so if you go into the Hunch Design Weebly, does everybody know how to get there to that? So if you go to hunchdesign.weebly.com and you go to design and prototype resources and you click on that, then you'll get to the ISS tools. It's a PDF file that they can download, and this is the file. So it shows you, you know, all the different kinds of tools that they have access to on station. Glenn took a lot of pictures and put these on there for you guys.
And so it's not just the toolkit. It includes some of the other obscure toolkits too.
Yeah.
And so it'll give you a really good idea of how they do some of these, what kind of tools they already have. I'd say that it represents probably about 95% of the hand tools that we have on the station.
Yeah, and some of these big tools, I mean, obviously like this big drill, you're not going to put that on the knee board, of course. So.
And there's so many different designs that a general little sack would look like the best, because you couldn't design something that would fit everything.
Yeah, you might even get some ideas on how you might want to hold some things on your knee board just by looking at how they do some of these things over here too, right? So like if you're looking at the like screw extractor kit or some of the other, you know, some of these about how they're holding things down, you may get some ideas from this as well.
Good.
Okay. Okay. I'll stop sharing now.
Yeah, and it's only the small tools, guys, that we want on that knee board, not the big things. The big things they'll carry around. So great, thank you. How about North Carolina? I think you're doing the knee board too. Do you have any questions? North Carolina School of Science and Mathematics. Chris.
Oh, we're doing the exercise harness.
Okay, so the knee board group isn't there?
Yeah, they're not here.
Okay, good. All right, any other knee board group here? All right. Well, then we will go on to the next one, which is the toilet paper dispenser.
Okay. Okay. So one of the things that I think people kind of miss out on this one is that the main purpose, this is kind of the funny thing about this is that everybody goes, oh, toilet paper. The whole point is for it in the bathroom, and that's actually not quite true. Yes, that's the first place that we might use this, but the other place that it might also be used is, you know, I'm thinking that we might actually use 3 of these, where one of them might be next to the galley table. And the reason is that when you have little drips and spills, you don't want to use a great big towel. You can use just a small little square to be able to clean up something. And so potentially if you're cleaning up after working with an experiment, you might have a couple of drops of liquid or blood or whatever that gets away from you, and you don't need to use a great big towelette to be able to clean something like that up. So potentially this has a use in a lot of different places on the station. Okay. So I
know that there's 2 schools, Jackson Hole, Wyoming. I see Connor there. He's I see the whole team there. They actually are not trying to reinvent the wheel. They're looking online, trying to find a good toilet paper dispenser. Do you guys have any questions?
I don't think we have any huge questions right now. We've kind of got a presentation that tells what we're doing right now. Would that be okay to share?
Sure.
Sure. Go ahead and share.
Thank you. Sorry. There we go.
Flo.
Yes.
I have one question. My kids have to leave in 10 minutes, and we just got reconnected to you. I'm so sorry.
Oh, that's okay.
Is there a possibility they could ask you a few questions about the exercise harness?
Yes.
Sorry.
Yes. Connor, do you have to leave right away from Jackson Hole?
Okay, let's go ahead and take
we will take Pasaic's questions. Thank you I want you guys to give me that kind of feedback, because I don't know who has to leave or who can stay. So that's important. So thank you. All right, what's your question? Say it.
Right. So we have a few, and the biggest one we have right now is there any other manufacturing standard we have to meet with the materials we use?
Not really. I mean, initially, you're just trying to get across a concept. So, I mean, if your first demonstration uses leather, or it uses, you know, polyethylene strapping, just like what you use off of a seat belt or a backpack, that's all okay. Right now, we want to see, how does your concept fit together? What is it? Does it have the direction and the comfort level that we're looking for? Are you using what kind of D-rings do you plan to use, or what kind of sewing techniques do you think are important to be able to get across the right feel, or be able to handle the forces that we're talking about? So your materials are not necessarily all that important at this moment.
It's your design that's really important. So
That's right.
be creative in your design, and we can always manufacture it in the materials that are required for a space station.
Right.
All right. Another question would be, can we get the exact dimensions for the floor space?
For which space?
For the floor space where the exercise harness will be pinned down to.
Yeah, and unfortunately, I don't have that. Right, we don't have that information yet. You're trying to keep it as small of a space as you can. Now, so I mean, if I said, I don't know, I'm looking at some of the floor tiles in my office here, and I'm saying I think they're like about 18 inches square. If you said that you get something like 22 inches square, that's actually a good start. Does that sound okay to you?
Right, so around 22 inches squared?
Sure. And yeah, don't hold me to it, but it's a good beginning. If you can keep it smaller than that, then that's terrific. It's going to have to be the width of somebody's shoulders. Does that make sense?
Yeah. And for our last one, is there any other is there any other research we should keep in mind, given like things that happen to astronauts in microgravity, that you want us to emphasize on?
No, but remember to keep it so that it's cleanable, right? Because I suspect, I don't know how many of them, how many of these we're going to get to send up. It might be that they get one for all 4 people on board. It might be that they get one for 2 people or something like that. So keeping it as minimal as possible is a good idea. But you also want to make sure that you're preserving the comfort, so that when I'm using this for 2 weeks, I don't come home with a bunch of rashes on my arm, on my shoulder blades, and things like that. Okay. Other thoughts?
Any metals? Any metals we can't use, or materials we're just strictly not allowed to use?
No, not right now. I mean, if it's I don't think you want to use magnesium, just because it could flame up on us or something like that. But some things, if you can save weight by using some aluminum in some places, that's great. But if aluminum isn't strong enough, go ahead and get steel. Okay.
All right. Do you guys have any other questions?
No. Actually, you just answered their question.
They said
no. I told you no.
I think we're good with the exercise on this.
Okay.
Okay, good.
Thank you.
Good questions.
Okay. Let's get back to the other team.
Yeah, we're going back to Jackson Hole, Wyoming, from New Jersey to Wyoming. Go, Connor.
So, I think we made a bit too much of presentation, but we'll just show you what our idea is right
Just
now.
show me a slide or two.
Yeah. Oops, let me open that.
And Aaliyah is also on the team. Wave at Aaliyah.
All right, so here is our final idea. We want to have a lid I'm sorry, we're all over the place right now. We would like to have a lid that is pushed down on top of the toilet paper by a spring, then have a little roller that you can move the toilet paper out with. Yes. Yeah, we looked at some Japanese designs where they had one-handed toilet paper dispensers and kind of came up with this and have been adapting it for use in microgravity.
Okay, very good. How are you planning to make your first prototype of this stuff?
Right now we are 3D modeling it. We hope to 3D most of the parts, and we will. Aaliyah, my partner, is a very talented machinist, so she can fabricate all the parts that need to be made out of metal.
That is excellent. That's exactly what I like to hear. When you're talking with when you've got the right people that know how to make the parts and how to design the parts, you guys start thinking and talking alike, and so that's a great way to start off. What's this black part in the center I'm looking at?
This black part, that we actually were going to ask questions about that. We have one design where the black part would screw onto the end of this and kind of be like a knob, so you could unscrew it and slip the toilet paper on. We're also thinking about having it be like spring-loaded, so you just push the toilet paper in and it will.
Okay. All right, and anytime you can avoid parts that are going to separate and could get away from you or float away by accident, try to incorporate it so it's something that, I don't know, so that it's all as much as one piece as you can. So
what do you think about like putting that knob like attached to a chain or something that would go to the rest of the machine, or is that
right? Tethers are okay, although they can still be problematic. So if you can, so like for example, instead of having something that comes off, I've seen, I don't know if you can see my picture here.
Okay, let me exit
Can you
out.
see me okay?
Wait, he has to stop sharing.
Yeah.
Sorry.
And then double click on my picture or else it might show up, I don't know. So
How do we double click on this picture?
yeah, just
There you go.
Now, can you see me?
Yep.
Okay, so imagine this is, let me see if I can see myself here. Okay, so if this is that rod that's going to hold the toilet paper on there. Imagine you have a piece that comes out and it kind of, like that, and that would keep it on there. And so kind of a pivot.
Yeah.
That's one thought. Don't take that as the best idea. But look for ways that you can keep all of the parts together so that I don't have to go hunting for it when the airflow pulls it out of my sight and I lose track of it. Okay? Otherwise, I think it's looking really good. Keep it up.
Thank you so much.
Okay. Anybody else have questions on the toilet paper dispenser?
Laurel, I see Laurel from Montana is on, and I know they're doing the toilet paper dispenser. Linda, is Marissa there?
Hi, Flo. This is Linda, and you can't see me, but I'm here. And we're over a lunch hour right now. So they are, I'm really sorry Marissa isn't here right now. They're going to be back in about 10 minutes, and all those students will come in.
Okay.
We have some here, so we really can't speak to that right now.
Okay, that's all right. And I got this recording, so I hope it's all right. Tell me, anybody online, if it's not all right for me to share this recording, because I have it recorded. Thank you, Linda. All right, anybody else doing the toilet paper dispenser?
Yes, we are.
Okay, who's we?
Does the C-track connector have to attach to the dispenser, or does that have to be part?
I'm sorry. Say it. Yeah, say it again.
Does the connector does the connector for the C-track have to be an actual part of the dispenser, or can it be an attachment?
Let's see.
On the slide, Glenn, you said that the toilet paper dispenser should be connected to the seat track.
Right, and that's to call it a requirement. I guess I shouldn't make it a requirement, but it's the more likely method that we would attach it. You want it to be something that's going to be real solid, so that it's not going to you don't come in and bump into it and it floats into some other place. Seat track is a real solid way to attach to something. Let's see. There's a few people that were looking at the Velcro bars and suggesting that they find a way to attach it to those, which isn't a bad thought either. Probably Velcro is not going to be strong enough. So I don't know. Did you have some other thoughts? What kind of other things were you considering?
Well, I'm planning on making the connector for the C-track an actual component separate from the dispenser itself. So we design the dispenser, and then we make the piece that attaches to the C-track itself separately. Kind of like we screw it in.
Oh, okay. Do you have a picture or anything that you can show me?
Right now we're on our concept sketches. That's why we're wondering if we have to incorporate it into a design sketch, or is it just separate?
Oh, okay. We'll have it in the design sketch so we can see it. Let's see. I suppose it could be a separate part, but you don't want things to float away from each other. If I detach it from one place and then it starts floating away. So trying to keep them together is a practice that we work on pretty hard.
Okay. I'm also, are there constraints on the possible materials like plastics and maybe aluminums?
No, not so much. I think it's very possible that we could print either some or all of the parts, but we would probably be using Ultem. The kind of materials that you want to demonstrate with would, I mean, if you've got ABS printers or PLA, that works just fine. The Ultem is a little bit stronger. Obviously, aluminum is something that we use on a regular basis, and that would be terrific as well.
Okay, thank you. I have one more question. If we do use metals, do they have to be magnetically neutral so that magnets don't attach to the pieces?
No, they do not. So if you have some that are magnetic, and some, I mean they're ferromagnetic materials, you use some iron or steel or something like that, and that's fine.
Okay.
Okay. Trying to keep it lightweight is good, right?
Yeah,
but that's fine.
Is there a weight range? Maybe a limit on the weight?
Not really. Not at the moment. We're talking about flying 3 of these. So I mean, if it weighs 100 pounds, no, we're not going to fly it. But if it's on the order of 5 to 10 pounds or something like that, I think that we're probably within the right range.
Okay, thank you.
And remember, it's the design of it that's most important right now. We'll work with the material that we actually build it with. That's like the second step. But worry about how you're going to design it first. Good question. Good. So that was Passaic County Technical Institute. Who else is doing the?
We kind of have one more question if you can.
Sure.
Sure, go ahead.
So the toilet dispenser, on the PowerPoint when we were looking over, it didn't have really any dimensions for the dispenser itself. It just had dimensions of a toilet roll.
That's right.
We were wondering how big it needs to be. I know it needs to be small, but like we need dimensions of it.
Yeah, I mean, so we don't have a dimension that says you have to be within this, but the answer is that just you want to keep it as small as possible. So I mean, I think I got one here. Hold on. Oh, I thought I had a roll of the toilet paper here, but I mean it's.
Yeah, a lot of our schools actually contacted the company that makes it, Georgia, and they sent them toilet paper rolls.
Oh, good.
Horrible.
That's real nice of them.
So yeah, 2 schools did that. So if you need a toilet paper roll, just call the company. They're really into providing us with it. If you can't get it, just tell me. I can borrow some from another school because they don't need 4 of them. So.
Okay. So, I mean, you can imagine if you can make it as small as just the toilet paper roll itself, that would be terrific. Imagine if you just put sheet metal around it. You know, that would be a good beginning. And then if you have to build out of that to be able to make it attached to the wall and things like that, just keeping it as small as possible is what we're looking for. Okay?
And the rolls itself, it doesn't have to have the core inside of the roll.
That's right. We're trying to get the type of toilet paper that I'm suggesting is it does not have a core because it's one more piece of trash that we don't want.
All right. Okay.
Okay.
That's all our questions. Thank you.
Okay. Sounds good.
Good questions. Good. Anyone else on the toilet paper roll until we're going to go to...
Gotta go.
We are Fairport is.
Thank you.
Fairport is on it.
No one else on toilet paper. Let's go to food preservation.
Oh, okay. No, Fairport. Go ahead.
Fairport has toilet paper?
Pocosin has.
Oh, Pocosin.
Pocosin has more toilet paper? All right. Do you have some questions for us, guys?
Yes.
Awesome.
Does anything special happen to the toilet paper when it is in 0 gravity?
Not really. There's as far as I know, we haven't flown a roll of toilet paper yet. And so the one thing that you want to consider is just that, you know, we don't have cats up there that are going to start, you know, kind of pawing at the paper and give you a great big in, but there is airflow that might try to roll it off of the paper, spin the roll. And so you want to have a little bit of friction somewhere so that, you know, airflow is not going to make that toilet paper spin and just deposit its whole contents into the cabin. But other than that, not really.
Okay.
The main purpose of this of the shield on here is to protect it from water and things like that, and for fire. We don't want to have, you know, a fire starts and then suddenly you've got this flaming toilet paper roll. So that would be bad. Okay.
So you want most of the toilet paper roll covered because of fire?
Yes. It's a big roll of something flammable, so we want to make sure that it's safe from fire.
Good. Okay. All right.
Other thoughts?
No.
Okay. Now, I saw that. I saw that Fairport had some questions. They were waving their hands. What do you got?
So we have somewhat of a presentation.
Go ahead.
So we have our first prototype here, and it looks inordinately complicated, but that's just to accommodate prototype. So basically, it uses a roller system. Do you want to bring up the presentation?
Yeah, I'm doing it right now.
Okay.
Let me get back to the
How do we screen share?
I'm doing it.
Sorry, just a second. We're trying to screen share a presentation with you. Yeah.
There we go. I think you guys can see it now.
There you go. I can see it.
I see it. I will. Where is it? Right there.
I like your patch. That's funny.
Oh no.
So basically, our concept it involves this is a complicated version because our actual thing wasn't much smaller. We didn't have resources. We had like bicycle gears and stuff. So
and plus, the cardboard wasn't strong enough to hold the gears, so
yeah.
we had to make this the gear kind of a panel.
Okay.
So that's all gonna go in the actual thing as just to make it work in the prototype. So how that works is there's an output there that is spun by this belt, and so it starts with that. There's a handle which is sort of squeezed.
Going back to the belt, if you guys don't understand it, what's supposed to happen is if you see the blue
little the blue pipes,
rollers.
Blue rollers. The handle is supposed to move those, and the friction's supposed to move the belt. There's 2 layers to the belt. One is on the rollers, the other one is on the toilet paper. Now, me and Ryan saw that this might not always work, so we decided the rollers are we're gonna try to get little teeth on them, and on the second layer of the belt, the bottom of it, we're gonna get little divots on it, so the teeth can hook into the divots, and when you roll it, we have a greater chance of it actually working instead of just.
So that'll sort of increase the friction there and make it be better in that aspect. So yeah, so as I was saying, this handle is pushed down. It's sort of like a squeeze. There's a bottom part and a top part. The bottom part is not actually there in that picture, but so that would sort of ratchet. You push it down, and it would turn a gear, which is within it, and that in turn turns the belt. That in turn turns a chain, which you can see turning there.
Wait, go ahead and push play.
Yeah, you got a video.
Stop that. So we've got it sort of moving there just to give you the idea that that chain is hooked up around the bottom part, the belt chain interface down there.
Okay. So this is hand crank driven, or is this electric, or what are you thinking?
It's not electric.
We would have done electric, but the
requirement
said that we couldn't.
Said that we shouldn't, and so we basically have it so that every time you squeeze it, the gearing on the actual one will result in like maybe 2 squeezes, and like 1 sheet is then pushed out by that. 1 sheet of toilet paper.
I'm going to go back to the whole design here. This is definitely not what our final version is going to look like. Like we said, it's a rough prototype, and these are mostly supports. The next one we're going to 3D print, so it's going to be made out of plastic, and it's going to be a lot more pretty than this.
Yeah.
A lot more pretty and a lot more functional as well.
Exactly, and it's not going to have all the tape.
Okay. So my first thought is this looks awfully large. Does it need to be that large?
It's approximately 10 inches by 10
Yeah,
inches, which is about.
We're gonna go back to if you just look at the main box on top.
Yeah, that central the main box on top is the actual size.
Yeah, I don't know if you can see my mouse, but I'm gonna try to outline it with the mouse here.
Okay, I can see your mouse.
That's mainly what it is. It's not gonna be too big.
It's basically a little bit larger than the roll of toilet paper. There's like a belt around that, and then just the box around that.
Here you
But then you've got the big gear down below.
Yes, that's just because we only have bicycle gears. When we actually 3D print the gears, they will be contained within the gearbox that we have on it.
This was my idea and Ryan's. We were going to try to get it with. We wanted to get it in the gearbox originally, but the cardboard wouldn't hold it. That's the only reason why you see the giant gear right there.
Okay.
It will be inside of the box.
Yeah. Okay. So what's driving you to having all the gearing?
That's just to basically that this is sort of later shown that the handle turns the gears, or it may be just sort of a wheel of some sort to turn a belt, which will also be within the gearbox.
That was the problem we were really stuck with in the beginning. We didn't know what to use, and I thought, why not use bicycle gears?
Right,
and
just for the prototype sort of thing.
And the gears, of course, the final ones are going to be a lot thicker, the teeth are, so they do connect much better.
They'll be like belt gears as opposed to strong. The belt will interface with these rollers that you see here. They're basically turned by that belt, and those in turn turn the inner belt.
Well, what I mean is, toilet paper really kind of spins pretty easily on its own. I'm not sure why you would need any gearing for it.
Well, that's the thing. We didn't want to. The first thing we thought is, why not just put it in a normal container and have the astronauts pull it? But
we don't want to have any bit of it out, like potentially to wind. You said there was air activity on the station, and or getting wet or flammability, which were both specified in the constraints. So we wanted it to be fully contained. Now, what you see open there would be covered in clear plastic, is what we're thinking, but this is just, again, prototype.
And maybe put like a flap that opens and closes on hinges. Just so
that,
it is.
that could be a way, but like it'll just be a small slot is what we're thinking that will be open. So rather than having them go in and pull it out physically, which could also rip the toilet paper and cause internal jamming.
Yeah.
This whole belt will apply pressure equally across the face of the roll so that nothing rips or jams, because ripping and jamming were two big things that we thought could be major problems with the
Okay. I'm just looking for you to try to keep it as simple as possible.
Yeah, it'll be
I mean,
much simpler in the final one. Yeah, we definitely agree with that.
right. And part of what I'm thinking about is that, you know, it's one thing for it to, I'm glad you're thinking about the jamming. You don't want it to get stuck in there and jam, but it's also easy. How does it compare to I open it up and adjust it and then put it back in, as opposed to having a bunch of mechanisms that might cause the jamming themselves? And so the simpler you can keep it, the fewer the moving parts, better it is for maintaining it, and also for, you know, I don't want to have to I don't want to have to oil this thing. I don't want to have to do all kinds of other things to keep my toilet paper dispenser functional. The simpler, the better. Okay, so I like the idea of having something that helps push it out, but I also don't want to have something that's pushing it out at the expense of, you know, making it huge and very complicated. So try to minimize the number of parts that you're going to have on there. Does that make sense?
Yes.
Okay. Okay.
Pardon me, this is Picosin. I have one from the exercise harness team who needs to leave but has another question.
Go ahead.
So the harness is just to it's just to be comfortable and hold them down as they exercise, right?
Let's see. Now wait a minute. Where am I going? You're a Picosin.
Picosin. That's the.
Gotcha. There we go. Yeah. Okay. So you can see me okay?
Yeah.
All right. Let me see here. Let me see me so I know what I'm doing. All right.
Glenn,
Yes.
did you want me to say anything in regard to this as far as
Sure. Go ahead.
the exercise physiology part of it? Okay.
Yes, please.
So, one of the biggest aspects that they're looking at for this, because you only have a single point that you're going to be, they have like a pulley system, and there's two companies that they're working with. One is going to be like a kind of a mechanical flywheel, and another one is an electrical one, but it has a single point that you're attaching to. So when you're dealing with that, because if you look at the treadmill, you know, the treadmill harness has 4 attachments. It basically has 2 on each side of the hip. And so that helps to distribute the loads properly. So the biggest aspect of this, the reason for the harness, is really to help develop proper loading, okay, on them skeletally. So really part of your design team should be focusing on like the physiology of it. Okay, so you start looking at skeletal loading, muscular loading, things like that, because when you're talking about, you know, having that single point, it makes it much more difficult to try to develop something that is going to have the proper loading, so that you're not putting too much pressure on the shoulders, or you're not putting too much pressure on the hips. And you don't need to ever be looking at this from the standpoint of like a you know, like a climbing harness, because if you think about it, like the single point from a climbing harness is a different kind of load feature than what we're looking at. Does that make sense?
Yeah, I think, yeah.
To everybody? Okay. So I don't know. I know Glenn was going to stand up. I think he was going to try to demonstrate something.
No, that's fine.
Okay.
So, for example, like the climbing harness, like you're saying, it would be attaching more closer to your belly button, whereas this is going to be an attachment point, essentially.
It's really between your legs.
Yeah, between your legs, probably about halfway between your knees and your groin, somewhere around in that area. Okay.
Okay. Thank you.
Other questions?
No, sir.
Is there any other school that has to leave shortly that has a question? Okay, good. Did we cover everybody who's working on the toilet paper dispenser? All right, so let's go on to, do we have people here working on the food preservation? Anybody here working on the food preservation? I don't know if anyone.
Yes, we are. Glenelg High School's here.
Oh, Glenelg, yes, yeah, I remember you guys. I kept telling you should do something with the algae in food preservation.
Yeah.
Let's hear what you got.
All right, we do have a question for Miss Westover.
You got it.
So last year, you did work with a Glenelg group that was working with like UV light killing bacteria, right?
Yes.
Yeah. So we were wondering if you still had their UV light emitter from last year, because we were looking to use that as part of our food preservation process.
That is a question for Glenn. I think he took off with your stuff.
Okay.
No, we've
wait.
been looking at that. So
I
Glenn
think it's
probably
right
has
behind. Is that the one that's right behind you on the floor there?
Yeah.
Allie?
Yeah, I think so.
I think it's in the box.
Yeah. We are looking to, and I think Glenn, so have you already been talking to this school then about how we're trying to get them to work on some new ideas, and then I have a school in Colorado looking at that too, and then trying to maybe combine some thought processes. What kind of conversations have been had yet?
I think we were looking at three or so schools that were.
Okay.
Fairport.
Fairport was the
is
one.
doing the UV light.
That's right. And I had a couple other schools that were also doing it. And
But Glenelg is thinking of doing the food preservation, and at the end, attacking it with the UV light to kill any germs after it's all packaged. So that's why they're asking about. Is it Glenelg? Is it because you need a UV light?
Yeah. We were looking to try to use last year's group's UV light, so we wouldn't have to go find some other
UV light.
Yeah.
Okay.
Last year, Allie, up at the New Jersey end of the year ceremony, you had taken the wand back from our group here, and that they had prototyped with.
Is that the one you got there?
Yes.
Okay.
Yeah, that's the one that we went over. We actually worked with the microbiology team over here at NASA, and we've been talking with them about kind of making like a kit type of version that would include kind of incorporating these multiple school ideas that they had into kind of a kit, if you will, almost like if you had a fanny pack and were to put all this stuff into, that you could then use. So we're kind of still in some developmental processes there for that, but we can certainly get back what you need to your school if you need to have that.
Okay, no, I mean, if you guys are using it, we do have a couple bulbs left. We'll just, and we can re-breadboard a new setup and stuff. So we do have bulbs still from last year that we got from the Crystal IC company that we can go from there and re-breadboard something new again.
Well, I think are we still working? Do we still need that, Glenn, or can we send it back?
You're
muted, Glenn.
You're muted. I can hear you across my cubicle here.
Okay. Yeah, I think we can probably send it back. No, I think let's talk on that, but let's see what we can send back to them. If they need to use it, then I'd like everybody to get use out of this thing the way they need to. So that sounds good.
Okay. Sounds good.
All right. Thank you.
Thank you.
Any other questions on the food preservation? Glenelg, do you have any other questions about that?
Like the shrink wrapping or the foam or anything?
I'm just curious what Glenelg's trying to do with the food preservation. What are y'all?
Share what you're doing.
All right, so basically we wanted to attack the problem from like a number of different ways. So there's like biological contamination, like germs and stuff, that we'll take care of using the UV light. But then there's also ethylene, which is like the ripening chemical that would cause things to go bad that way. So there's like a number of chemicals that can be used to absorb ethylene. So one of them is activated carbon or sodium permanganate. So we were thinking of vacuum sealing produce with an ethylene absorbing agent like with it, and then treating the whole package with UV light. So that way we can like avoid microbial contamination as well as removing as much ethylene as we could to make things last longer.
Okay, so you're talking about like pre-treating like the inside of the bag with UV light before you vacuum seal it?
Yeah, that is involved. But once you package everything, you can still treat the whole bag with the UV light since it's transparent.
Yeah. Okay. And that would be like kind of like the idea behind that would be that would be a pre-launch kind of thing.
Yeah.
Okay. So that's interesting. I like that concept.
That is interesting.
They're
Check
really
to see-
just using East Troy's procedure of a vacuum seal with a little package of something to absorb the ethylene, but they added the UV light at the end, which might be really good.
That's a good thought. Check to see what the okay, so it's transparent for visible light. Check to see if it's transparent for UV.
Yeah.
I know that UV gets blocked by a lot of things, so that consider that. Okay, good thinking. I like it.
All right, thank you.
Glenn, just to let you know that we did a lot of experiments with UV, and it depends on the type of plastic and the thickness of the plastic, definitely, how much gets absorbed.
Yeah, I agree. There could be some difficulties there, and it may mean that it pushes you to one particular plastic, or it may mean that you have some difficulties with it altogether. So, good thinking. I like it.
Or you could do the UV light before you package it.
The thing is with doing it before we package everything is that we need to do all of it in like a sterile environment. And, yeah, but we can do that. So yeah, thank you.
Sounds good.
Yep.
Great.
Is there any other school doing food preservation that's online? Nope. All right, good job. And is there any school that we didn't discuss who's doing the exercise harness with? I think we discussed the exercise harness pretty well. All right, so let's move on to the trash holder.
Trash holder? Oh,
Yeah,
okay.
so the people designing a holder for that little Sea Summit bag. And I know Laurel's there now. I see them. Hi, guys. You want to tell us a little bit about, is this team that's there doing the trash holder? They have two classes, so I never know which class is doing.
We actually, could you guys stand over there where they can see you? There you are. There
you are. Yeah, it is the class.
Sit down a little so they can see you. Okay. So, do you guys want to talk about what your ideas are? Go ahead and talk.
Well, we're doing rubber flaps so that you can stick your hand in, but the garbage can't come out. And,
Hold that up to the camera a little bit if you could. Yeah, I see. Okay, so you've got slits down the center.
yeah.
And that's similar to what we've done. The space shuttle has done some things like that, and they had mixed reviews on it. And it might depend on the type of plastic that you use for that cover. Another thing that's been helpful, I don't know if you can see me. Can you see me okay?
Yeah.
Yes.
Yeah.
Okay, so when you, the Russians do something where they have, imagine the same circular hole, and they have a sheet that goes over and then a sheet that kind of covers over that one, so that you have to slip your hand between them, and that seems to seal a little bit better. So you might try that as well, okay, and see which one covers, and you also have to think of it in terms of how long does it last, how many times can I slip my hand in and out of there without it remaining either in or out. and which one holds the smells in there better. Okay, so try experimenting with that with that cover and see how that works out. Okay.
And they just used a PVC pipe to hold the bag.
Right, and I think that's pretty smart for a good start. How does the bag hold into the PVC?
Right now, we just got it kind of taped in, but we've got ideas with little like clips inside of it where the drawstring can attach to.
That's a good idea. Having some kind of a clip or some kind of a ring that kind of clamps onto the bag itself is a good idea. You might even try, like, you might try sliding the bag over a piece of PVC that fits in or something like that. So that's a good start. I like what you're doing. Good job.
Good. Is there anyone else who's doing the trash holder? I don't think so.
Another comment for you on that trash holder. You want it you want to attach it to the galley table somehow. What's your method of how you want to attach it to the galley table?
Well, we know they have Velcro, and we know they don't really want too much Velcro. So we have ideas of on the back we have a piece of Velcro that can attach to any direction or place on it that they'd like. That's just for beginners.
Okay, and Velcro is a good beginning, but it's also not as strong. You might look into seat track on that as well, just because if you're trying to cram more stuff in there, you might be pushing pretty hard. So find something that'll be a nice strong hold for keeping it to the table. Okay.
And where you place those connections is important because the old bag wasn't placed so correctly so that when you tried to get trash in or out of it, it flopped.
That's right. That's right.
So good.
All right.
All right, so that's the trash holder. Anybody doing the cupola restraint?
There was somebody there. But I see somebody at Fairport had some kind of an object. Looked like no.
Yeah, what do you have there, Fairport? What's that? You got it. There you are. What you having?
So this is the double wall joint I 3D printed, and
yeah.
The arm. That's for the what's it called? Bogan arm.
Ah.
Oh, well, we're on those two now. You want to tell?
All right. Tell me about the Bogan arm.
I can share my screens. I have a little presentation of pictures.
Excellent.
All right, here. All right, can you see it?
Yes. Oh.
Oh, wait. Give me a minute.
Almost. You're doing it right.
Problems.
No.
Lots of problems. Sorry, the school signed them out. Yeah, the school.
Oh. It's after school there already.
Yeah.
Oh, man.
They're the East Coast, New York.
What's going on? Lots of help.
Okay.
It's a cool project, I swear.
I bet it is.
That's good.
There we go. Oh, I'm good.
You're good? Okay.
That's it. All right. Hey, oops, don't do anything too bad. All right. Here we go. Oh, boy.
Go back here. There, take it from there. I can see your pictures.
All right. Well, yeah. So pretty much, this guy here is the original design I had, or where is it? Well, there's a 3D model I have, but so the whole point of my project was I wanted to do universal joints on everything. So I made these two universal joints. This is just a prototype. I 3D printed it at my robotics. We have a 3D printer that we use. They fit together very well, as you can see right here.
Yeah.
And then I found a little 1/4 inch. It's originally it's some type of bolt that I used that was for what's called plumbing, but I originally got this one. Then, of course, I kept working and I completely CAD'd some stuff. Can I switch maybe?
No, don't worry about it right now.
No. All right. Well, here, let me go to my camera. So stop share. So
There you go. Show me what you got.
Camera here. I have, this is the, I again started attaching these little pieces I've made onto this guy. So this is the full-scale model of the bogan arm that I'm going to use. This will also have what's it called? Have Velcro on it. So just for added, if you want to put something on it, it's very simple. So yeah, this guy has the female and male adapter for each side, and then this is the mine's kind of a mix of multiple things. So this is the double wall joints. I decided to add to it.
Okay.
I 3D printed this and CAD'd it. So there's the files are all in my thing. All of the every single piece has a male and female port on each end, so they all fit together.
Wow.
Yeah.
Wow. Okay.
So
I'm with you.
We'll all have these little pieces on here. I'm gonna end up putting handles on these as well, so you can tighten them and loosen them. They fit together very well. I'm surprised actually how well they fit together. Like it's just it slides in. It feels like really smooth. And then of course the double ball joint has this little bolt here. It's a screw. I had to redesign this a couple times. I worked with a couple teachers. This guy, you pretty much just tighten this bolt. I'm gonna have a butterfly bolt instead, just a little easier. And that'll just tighten that so it doesn't move. And you untighten it, and you can move pretty easily. I also have a few other things in CAD that maybe I have as pictures. I don't know. We'll
Okay. Show me your swivel joint there again. That's really cool. I like that.
Go back to that. Yep.
And he's a team of one.
Uh-huh.
I remember that.
So I pretty much just made a double ball joint right here. It's very simple. I also CAD'd a triple ball joint, which has 3 connectors to it. So it goes with male to 2 female, and then plug in 2 different arms if you want. And so that pretty much is going to be the main huge design. I'm going to have tons of different adapters. Also the flex arm. You guys know what that is, the camera mount one?
Yeah.
I CAD'd a version. It is 3D printing now. The guy was supposed to be here today. He from RIT. He's supposed to be here now. He's not, but he'll come here soon. But yeah, so he pretty much I got in touch with the guy at RIT. He 3D printed me the entire thing and multiple pieces of it. Again, they're supposed to show up today. They're not here yet.
Okay.
But
It's all right.
yeah, so those will be coming soon. But so I pretty much have there's scaled down versions, but there's I think 3 of these, I think 2 of these, and then there's the flex arm, and there's also an adapter for the seat track mount, or not seat track mount. It's just a bar. It's one of the bars in the ISS. I don't know exactly what it was. I modeled it directly after the one on the ISS, so I have a little clamp on there. It's just 2 bolts that pretty much are 2 pieces. They go around the bar, and then you screw in the bolts, and it stays together. And it has a male and female end on each side, so you can plug it in. Every single piece, my whole point was every single piece has to have a male and female adapter, so you don't have to go for 100 different adapters.
Yeah.
And then especially with the flex arm they were having a huge trouble with. They wanted more adapters, so I solved that problem as well. I have a few male to female and female to male. So all those are in CAD files that as soon as I get the final the full 3D printed thing, I can figure out some of the flaws. First off, when I 3D printed it, I put the word bogan arm on here in like italicized letters, and it printed, which I didn't want, but that'll obviously be fixed in the final version. Also, size-wise, I changed a few things. This is a cardboard model I made. I found out the original one when I made was really big and like thick, so I scaled it down a little bit. It's really nice now. It's a perfect size, perfect length. If you need to put multiple together, you can just put the double ball joint and have multiple chink together. Yeah, that's pretty much it. I will have to implement some maybe camera mounts if I can get those. Question mark?
Right. Yeah. So I really like the white piece you've got there. I don't know if we need the length of the cardboard piece that you have there, but let's keep that in mind. Yeah, I don't know that we have. I don't know it needs to be that long.
It's about 1 foot long.
Yeah. That's probably, that might be a little bit longer than what we need.
Yeah.
So imagine if you've got a white piece on each side.
Yeah, 2 of these would add a lot of length, wouldn't they?
That would make it pretty long. It doesn't mean that there isn't a need for it, but there'd be a limited number that we would want. And so where would we put this? Like I still need to attach seat track there. Where would you put seat track on yours?
So the seat track mount is again going to have probably a male or female adapter that will mount into the seat track and then just have you pretty much pop it in and tighten the bolt. So I will have to model that. I don't have exact dimensions of the seat track. That's the one with the different ridges and stuff, right?
You can get that right offline. So if you go to just type in seat track, there's U.S. Cargo and several others, and they have seat track. You should be able to get seat track from them from their CAD drawings for you.
It's an online thing. You guys bought it?
It's something you can Google it and get seat track dimensions.
Okay.
But is it the same that you use on the ISS, Glenn?
Yes. Yeah.
Okay. I can use that. Okay. I'll have to start modeling a piece that'll fit into there. It should be pretty easy. And yeah, you have male, female. Everything will go together. That's the whole point of this thing. So I solve multiple problems with one solution.
Okay.
So your parts are on the way upstairs. Somebody ran down to get them. If you
they're
they're
coming.
They're like on the upstairs right now.
They're coming right now, which is last minute. But,
Okay, that's all right.
Did you have other questions? For
another thing. So I just realized the ISS has a 3D printer, right?
Yeah.
So all these parts are 3D printed, and my final design will probably be in aluminum. But if something were to break, would they be able to print new parts? Could they print new parts? Because I have all the things as CAD files.
Right. Some of them can be printed.
Obviously, nothing like this big, but yeah.
Right. They have a limited print bed, of course. It's not that. It's I want to say it's like 6 by 4 by 5 inches or something like that. But the other thing is that if there's any kind of, it has to be something. You have to print something without support material.
Oh.
Because if you have support material, then you either have to pick it out, and that means that now you have stuff that gets in your eyes, or else you have to put it into one of those some kind of a bath, and we don't to be able to dissolve it. And we don't have that kind of capability either. So you have to choose your designs so that it doesn't have that kind of material. Okay.
And the 3D printer engineers are coming to the December 7th on Wednesday. So if you have questions for them, I can't remember your name. What's your name? Is it Chris? What is it?
Spencer.
Spencer. Okay, Spencer. Great job. And is the RIT guy the one who came to our hunch kickoff there?
Yes, he is. He said he pretty much printed out the entire thing, and when I'm final CAD design, he's going to be metal printing the entire thing out of, I think, aluminum. So yeah, that will be interesting to see if the entire thing will be.
Wow. So he's been a big help.
Exciting.
That's really good. I can't remember his name either. What's his name?
Mike Buffalo.
Mike. Okay.
Buffalo.
Right.
That's exciting.
That's really cool. It's amazing to see. I know you had all these thoughts when I was there, and you really come through and put them on paper and in the machine. That's super.
Excellent. Good job. Good thinking.
Great. So when Mike comes, school's kind of big, so it takes him a while.
Okay.
You guys want me to come back on and show you?
Yeah, when he comes with the parts, you come back and show us.
That's fine.
I know we have two teams waiting here. One is from Jackson Hole, and they are doing the loose container, and I would love for them to see. Hi, Mike. And the other one is Brianne from Platt, who is working on the pin kit. She's the only one I know who's working on the pin kit.
Okay.
Do you guys have to go, or can we finish with Fairport?
Yeah.
We have some time in class until about 2.
Okay, so they're on mountain time, so that's better. How about you, Brianne?
I'm good to go. I actually left school early.
Oh, okay, good. So let's see what Spencer has there. Spencer, we're going to look at your work then. All right, Mike, thank you so much for helping them. That is super. I really appreciate that.
Oh, you guys are on mute.
Let's see what you just got 3D printed.
Well, we were just doing scale models to get a more physical, full assembly together, so it's scaled.
Okay.
And we're going to probably look at manufacturability and feasibility in the next few weeks or week or so to try to get them some better parts.
No, that's looking good. It's pretty exciting.
So yeah, these two pieces are the scaled down ones.
Scaled down. So we're going to try to put a full assembly together.
Yeah.
Wait, hold those up again. I'm not sure I'm quite following yet.
Well, so this is one of their pieces, and then this is
the small one.
This is the small one. So this is actually populated with all the parts that they need.
Yeah.
Excellent. I see what you're saying. So that it's, there could be good value to small parts as well, because not everything has to be great big, right?
Yeah.
So no.
And the time that we have to work in, and when we have machine availability, it might ultimately end up being a scale from us that we can help with.
Yeah.
Right. Well, and realize that the whatever flight materials we start looking at, that we'll end up doing it with Ultem if it's a 3D print, just because that's a flight ready material.
Yeah. So I have Peak and Palm.
Oh, do you? Okay.
If you want to give them an example of what Ultem functions like, we could try a part in Ultem.
Yeah, and you'll find that there's some different properties with it when it, how it slides against each other and things like that, different than other materials. But so a little bit of experience with that is good.
We did a CubeSat out of Ultem last year.
You did a what?
CubeSat. It's mini satellites.
Yeah. Okay. No, that's cool. I didn't know that.
And Mike, I want to introduce you to there's Glenn Johnson, who you're talking to, and Ellie Westover, another NASA engineer. They're both at Johnson Space Center. Mike, I remember MakerBot things. Do you want?
I work at RIT in their advanced manufacturing lab, so we do functional printing, a lot of circuitry, but we have the other printers and a makerspace to accommodate projects like this.
That's great. Okay. Well, that's terrific.
And you can tell Blake. It was Blake who told me to contact RIT that there was somebody there interested in helping us. So it was Blake's idea in the first place. So that's great. That came true. Thank you so much.
All right. Okay. Do we want to go to one of the other schools there?
Sure.
Yeah, I think we're ready if you guys are
good.
Okay.
So this is Jackson Hole in Wyoming. Jackson, Wyoming. Do you have a ton of snow?
It's been snowing for the past 4 or 5 days.
Oh my goodness.
Okay.
I made it there right before it started to snow. So
Great timing. So our project is dealing with things coming out of bags when you open them.
That's right.
Trying to keep them in so that you don't have to recollect them when they flow into the microgravity environment.
And so if you recall, when we had done a Zoom conference earlier, then Flo had showed us one of these clips.
That's right.
And we really like this idea, but we came across something that would work even better. So it's this clip, and there's no moving parts. It's just as it is. And you take your bag, and you can fold it anywhere you want, and you'll guide this onto it, and it slides through, and it's watertight, so we could. We really like it because you can also have it on the bag still, but have a small portion of it accessible. So if you had small pieces, you could still access them.
Yeah.
And you can slide it all.
It works pretty well, but there are definitely some design flaws that we'll be addressing, in addition to making it something that an astronaut could use with their mouth. Flo came to Jackson and explained to us that a lot of the time you don't have 2 hands to work with, and sometimes you have to use your mouth, especially when you're on the ISS. So we are thinking about making ways that this could be Velcro accessible and operated through.
Add a mouthpiece on the end so that you can put it in your mouth and
like a bite stick.
Yeah.
Okay. No, that's good thinking. As simple as that is, I really like that. yes, I want to try to show that to some of the crew and see if they see some value for that. I think it's a great idea. Okay. I like seeing that one. That's good. What was? Show me the other one that Flo brought or showed us again, and it opens up. It's a clip. It's also really simple kind of stuff.
It doesn't puncture the bag as long as the bag fits within.
Yeah. So having a combination of a couple of these things might be valuable. So
yeah,
you might have three different versions and 3 different sizes for each of them, and that might have some value too. So that's good thinking. I like this a lot. Good job.
we do have a couple questions.
Yeah, go ahead.
About materials that could be used that we have access to, specifically with bag sizes. I'm not sure if you know how large some of the bags are on the ISS, how small.
Okay. All right. I know that we have bags this size. Okay.
Looks like you've frozen on us a little bit.
Oh, sorry. Let's see. I don't know how to unfreeze it.
Yeah, they froze. You didn't freeze.
You guys froze.
They froze.
Okay. All right. I don't know how to help them there. Can you hear me at all?
It's really cold there, so I'm not surprised.
It froze the picture.
Well, they got snow and everything, but I'll give them that information if they don't go back on.
I want to say that we've got sizes that are we've got a very large variety of sizes. Probably on the order of.
Oh, there they come.
There we go.
Good move, guys. You just have to go out and come in again.
Okay, you guys are all right? Okay.
Yeah.
So this is a common size. Okay, so it's on the order of like I don't know, it's bigger than a 1 gallon. Is that a 1.5 or a 2 gallon?
Yeah, it looks larger than a 1 gallon for sure.
Okay. And I know that we have larger ones as well. So on the order of like, on the order of like this size. Does that make sense?
Is that something where you want one of these clips made for that size bag, or are most of the things in that bag large?
Good question. I don't know that one. I think that just I don't think you have to demonstrate all of the different sizes. I think the idea of being able to show, look, we have things that are for, if you can show it on 1 gallon bags as well as smaller, I think that would be a great demonstration. And then if you have information that says, look, we can also do it with these larger bags, and they would be able to evaluate that better than me. So I mean, demonstrate with the small and say, hey, we can do this bigger. And everybody will go, oh, wow, that's exciting. So I think that's the way to do it. Don't try to show everything. Just try to show the concept and say, this is how simple it can be. Okay? That's great. Good job.
And then we also, so we were talking about having a mouthpiece. And earlier you had mentioned to a different group that you wanted things contained in like 1 unit. Would
That's
you
right.
want the mouthpiece on these to be detachable, or would you rather it's 1 unit and not there doesn't have the potential?
It's better if it can be 1 unit. Okay? Just because, how about this? I know that I have to produce and put labels on anything that can be separated.
All
right. When they're tiny like that, it's hard to make labels. So. Okay. All right. Any other thoughts?
I
think that probably
think so,
covers it. Yeah.
Okay.
We just want to get your thoughts on the project up till now. So thank you.
No, I think it looks sharp. Good job.
Good job, guys.
Okay.
All right, now it's Brianne, and then we'll go back. There's some people that Laurel that I want to introduce you to. There's a engineer who comes in and talks about 3D printing all the time. So.
Okay.
Okay, Brianne.
All right. So far, I've tested my design for the hinges because I wasn't sure how well it'd work once we machined it. So my shop instructor helped me out, and we put it on the 3D printer and just printed like a little portion of it. So they slide together, and there's certain slots in it, and the hinge will line up. And the way it printed, it's a little rigid, just because the 3D printer was oriented kind of funky. So I sanded it down to make it a little smoother.
Very good.
So that's how far I've gotten testing my hinges.
Okay, now wait. This is hinges for which?
Pin
kit. For the pin kit. Because
pin kit. Oh, go. Okay.
Yeah, you guys wrote, I think it was in the PowerPoint on the stuff, you want it to be like out of a hard plastic.
It can be out of a hard plastic. Okay.
Yeah, so that's kind of what I'm going for.
Okay.
And with that being said, what kind of plastic would be best? I heard you say polycarbonate and Teflon earlier.
That's right. Polycarbonate and Teflon are two that we use frequently.
Okay.
And lately we've been started to use Ultem just because it's a printable plastic as well.
Okay.
And so that's also a good start. But what you do right now, I mean, you're probably doing ABS, is that right?
Yeah.
And that's just fine for your demonstration. Don't worry about the materials that you're using today.
Okay.
When it's when we're ready to build something for flight, we will help with all those materials. Okay.
All right. And then another question I have. I'm also working on the single stowage locker at my school. So I noticed that had all little holes in it, whether that be like for screwing it together or whatever. But I came across wondering, does the pin kit need pressure relief holes in it?
No.
Okay, awesome.
No. The holes that you're seeing on there are mostly for riveting. And that just because they don't weld it, they rivet it for mechanical reasons. Okay.
All right.
But your box may be it may be printed as two pieces and then you slide them together or something like that. That's just fine. We're not worried about this launches and once it gets up on orbit, we're not too worried about other problems with it. So okay.
All right. And then with the pages in it, I noticed there's 6 in the model you guys currently have now. Do I need to keep it at 6?
No.
Or can I condense it?
No, actually, I was just answering some other questions on that. I had, so some parts of your design might be cloth and some parts might be 3D printed, right? And so the point is that we're just trying to contain all of those different small parts. And so how you contain them, it doesn't matter so much. We just want you to come up with different ideas for how you might contain them. So, for example, I had one team, they said, oh, what if I used like a computer bag? You know how that they will unzip and then the whole thing folds out. And I thought, wow, that's exactly right. And part of what I liked about that is that most computer bags have, can you see mine?
Yeah.
They have, I got to make sure I know what I'm doing here. There you go. So like mine, I can unzip and I can get a few things, or I can unzip the big thing and get lots of things.
Yeah.
And so part of what I like about that is that if I have the things that I use most often, I can put in a separate pouch, in a separate location. And the things that I get that I don't need to get to very often, they're in a different pouch. And so, and that's part of the idea of that. If you use a 3D print for part of it, it might be that you've got your plastic box, you've got a cloth bag, and they Velcro together, or they kind of strap together somehow. And the things that I get to most often are in different places, so that I run a smaller risk of losing all these little things floating out away from me because I don't open that pouch very often.
Yeah.
Okay. So that, go ahead.
With the things floating out, I had a thought. So I don't know if you'd know, but like in sewing kits, needles come in that round little thing, and then you turn it and it opens.
Mm-hmm.
I was looking at all the things that go inside the pin kit, and it has these tiny little pins.
That's right.
So am I able to make something like that needle holder and then connect it with Velcro so then it can then be taken out?
Yes, and you might even go over to the sewing shop, sewing store, and if they have one, take that idea. You don't have to re-engineer it, right?
Yeah.
Take what already exists, and if you need to change it a little bit, change it a little bit. But if you can use what already exists and it works terrific, use it. That is good engineering too. Okay?
All right, awesome.
Good job.
And she's
I like that you're thinking of it.
She's the only one who's doing the design and prototyping at Platt, which is the school that's building complete lockers.
Yeah. Well, the other thing,
and she's a big part of that too.
Yeah, the fact that you're working with your the machining teacher on this stuff is really important.
Yeah.
One of the things that I'm really excited about is when I hear designing students working with the machine shop and the machine shop students working with the designers.
They're definitely helping me out a lot.
That's great.
Like big time.
That's terrific. That's exactly.
Well, and you're helping them out, so.
Oh yeah, definitely. Because I was talking to you about it when you came. There definitely is a gap in the dimensions somewhere.
Sure. No, that's good. Good job. Good thinking.
Right. Thank you.
Great. Thank you for being so patient too and waiting.
Yeah, no problem.
That's awesome. Thank you, Brianne. All right. So I see Ken sitting there. Ken, I want to introduce you to Ellie and Glenn there, and they are at Johnson Space Center. And Ken's been coming to our Laurel. He retired from New Jersey to Red Lodge, Montana. So you want to tell us a little bit about what you do there, Ken?
Oh, I'm retired from Verizon Wireless. I used to work in the phone testing lab, and basically we tried to destroy the phones before the customers did. Find all the problems. But I'm an electrical engineer, and I've got I started a 3D printing business, and I found that when I talked to Linda Wright here, we had a lot in common. Using Arduinos, programming. I have a little machine shop. It fits on the top of your desk. We're making small things out of metal and wood. I have a 3D laser cutter for making slightly bigger things out of wood and plastic. And like I say, the 3D printer, 3D camera to take pictures of things that I want to make out of plastic and wood. But the whole idea is I have all these capabilities, but what I really wanted to do was work in STEM, work with STEM, to get more kids going on this stuff. I want to crank out more engineers if we can, and recognize engineers and people who solve problems, and how to solve problems and how to make things from ideas, real world things. So that's why I'm here.
Well, it sounds like your initial job is real similar to us. We try to come up with the try to break the stuff before the astronauts do as well.
Yeah.
So.
Yeah. It's actually a lot of fun. So
it is.
Yeah, don't tell anybody. It's a lot of fun.
I'm already jealous of your shop at home because I want to do the same kind of thing. So
yeah, fortunately, we just moved to Red Lodge, which is this little mountain town about 40 miles away. And the guy who had the house before us, he had this really great garage. It's heated and electricity everywhere, lights everywhere. And I just started setting up stuff, and then I went in search of problems to solve. So I'm really glad to land with this group here. There's plenty of them. And just help people along and turn out engineers. That was what I was thinking. Education, how to solve problems, how to find problems, and think about problems. And if you don't know the answer, somebody else knows the answer, and you can stick your answer on their answer and come up with a third answer. So just all this creating and building, working with your hands and working with your mind, that's what I like to do.
excellent. I'm glad you're working with our students. That's terrific.
Thank you. I'm really enjoying this too. Thank you.
That's great.
Plus, I have to say he makes some of the best apple pie I've ever had.
Oh, wow. Yeah. It's just the internet helping me. So.
That's awesome. We really appreciate people like you make a big difference in our students' lives, and you could see how creative they are, and to be able to encourage them, it's amazing to see their ideas.
And, looking for the people who somehow want to be problem solvers. And I mean, everybody's a problem solver. It's just sometimes you don't get the opportunity to work with tools and create things. You know, you just have problems and you think all day long about them. But to be able to solve and build is really special. Really something we all need to be able to do.
Yeah.
So I see this is your second hunch class there behind you, and I think I see Brenda, and I'm not sure who else is sitting there. Who else is sitting there?
As soon as they move into view, would you move into view so she
Yeah,
can
because they're doing some interesting.
Everybody's here.
Oh my goodness! Yeah, now I can see you guys. I know they're working on that poker game.
Oh.
You want to tell us about the poker game? We didn't go over the poker game yet.
Yeah, we've got John Hill here today also. And
hey, John. So John Hill was a Hunch student. Now he works in computer programming in Billings, Montana.
That is awesome.
So he graduated college right here at Rocky and got a job in programming. And he comes to help at Laurel. He's a past student.
That's
and so,
terrific.
tell us about your poker game. We didn't go over the poker game yet.
Mostly we're just kind of covering the basics of programming. It's actually kind of an opportunity, I consider it to be an opportunity to be able to help the students learn programming. I know there isn't actually a programming program here at Laurel High School. Like, I didn't learn any programming until I graduated from high school here and went on to college. So any opportunity I can get to teach someone what I do, I find entirely entertaining and fun to do. I'm not the best teacher, I'm sure. That.
What language are you trying to program it in?
We're working in Java right now. I know that might not be the best of ideas for what we're hoping to do, but it's a good starting point. So we're kind of going through basic objects, kind of touching base on, I was teaching one of the students earlier about enumerations, just kind of going through creating their own card objects that we will eventually hopefully use as an array list of the cards, create hands off of that. So we're hoping to use a model view controller type setup. So I'm teaching them about that, different design patterns. I might just be jumping straight into the deep end with them, but I didn't learn any of this until second semester of college, so.
That's all right.
Yeah.
No, that sounds great.
Good. What's Brenda? Brenda actually is a sister of a Hunch student that I had many years ago.
Come over, Brenda. Come over here with
us. Come over here, Brenda. Tell us what design and prototyping project are you working on? She's actually really getting good at programming.
I'm going to turn this a little bit so she can come in here with Mr. Whistler. They worked all last hour on, I'm not sure all what they've been working on, and they can tell you where they've gotten started or stopped or whatever they're doing.
Also, like you're doing the kneeboard project, is that right?
No.
Now, which one is this?
We're working on the ATU panel.
Oh, okay. So, and that's the one where you press a button, it simulates the intercom, I think it's called?
Yep.
That's right.
Yeah, show them the ATU panel, Brenda. Can you get that panel and show it to them? So this class, you know, this was my original class. This is where I started the Hunch in 2005. And so we did electronics, and they're still doing electronics for Bob Zeke. And so they do some design and prototyping projects and some electronics still for Bob Zeke. So Bob wanted this audio terminal unit.
Yeah, that looks good.
So essentially with that project, they're hooking up these buttons. They're LEDs and buttons. And they're going to use, well, Brenda can tell you about where we're going with that.
So we're trying to work on getting the Arduinos hooked up, and maybe we're thinking about just testing individual buttons to make sure they work before we go on with soldering any more. We haven't soldered quite yet, I don't think, on it. The class last year soldered on it. I think Ms. Wright said that they actually got buttons working and were testing them individually. And then what we want to do is go in and try and test them after people in our class that are really good at soldering, so we can test them that way to make sure everything works before we just do everything. And if something doesn't work, then we're kind of in trouble.
So they're working on having the program for up to and around 24 of these buttons working in a variety of different ways, depending on how they're pushed and in what sequence, what order. So the portion Brenda's working on is Arduino programming at this point.
That's great.
Oh, sorry. What we were talking about the past hour was looking at the code and trying to figure out ways we could make it faster, and we can make it easier to read and easier to debug. C has a good set of code there. We're just sort of taking it to the next level where we can play with memories and arrays to make it faster.
That sounds great.
She didn't know any coding in September, and you should see her code now. It's awesome.
Work with LEDs and wiring. And we had a couple different groups working on the ATU panel, and I think today they finally got the speaker cover printed off the 3D printer. You guys want to bring that over and show us?
Yeah, and Bob's a 3D, Bob Zeke bought them a 3D printer.
Oh, that one looks good.
There's the speaker cover at last.
Fourth try.
Yeah. So they've designed that, printed it, and a lot of different pieces of parts are going to go into that ATU panel.
A lot of work. A lot of work.
You guys don't have to do the box, do you?
Pardon me?
You don't have to make the ATU box, do you? Just the.
No, go ahead and pull that front panel out, and then pull the speaker, the shelf out.
They made a shelf to put the Arduino and everything on.
Oh, I see.
So they've got the front that, show them the front panel. And then that shelf will go behind that to hold the Arduino and run the wires through.
Yep. No, that sounds good. So you don't have to have the whole box. You're just, this will be that mounts to the wall. So I think that's terrific.
It's
Good
just
job.
going to go into a cutout into his wall. He's got space back there.
Yeah, that makes sense.
That'll be a flush mount.
Anybody else in the classroom have a question about their design and prototyping project?
Any of you guys have questions?
No. Not really.
Okay.
I think we're good.
Good. Thank you for joining. I know you were here a long time. That was awesome.
Thank you. Thanks for all you do.
And thanks, John and Ken, for coming and helping out there. That is so awesome to have two mentors. That's really cool.
Okay.
All right, I think we are done, and I did record it, and so I can send it to you, and you can put it on your design and prototyping website there, your Weebly, if you want.
Excellent.
I really appreciate all your help. I thought that went really well. Kids are doing amazing jobs, and it's so great of you to give them feedback. That's important.
I think it looks great. Okay. Is that the end of our meeting then?
Yep.
Okay.
That's it. Thank you. Bye-bye.
Thank you, everybody.
Have a good day. All right. Bye-bye, guys. Thank you so much.